Action Agri Science 8, it's Mr. Brzezinski. I have another video for another exercise. This is the water systems exercise for freshwater and saltwater. I'm going to bend the computer down so you can see what I'm doing on the desk here. Step number 1 says label a cup distilled water. Suggest that we pour 100 milliliters of distilled water into the cup. I'm going to get my graduated cylinder. See if I can pour 100 milliliters in there. Distilled water is pure. It doesn't have any minerals in it. You can purchase mineral water, which would have minerals in it. Most water you find in nature will have some minerals in it, except for the water you find in the ocean, which will have salt in it. There's 100 milliliters of distilled water. Step number 3, list the components in fresh water. List the components in fresh water. You can write that down there. Second part of the exercise is to label a cup of salt water. You'll want to put 50 milliliters of tap water, which I have here in the graduated cylinder, into the cup. It's only half as much as the fresh water so far. Next, it would like me to put some iodized salt, 25 grams of iodized salt. I'm going to see if I can measure that on the digital scale here. That cup weighs 11 grams, plus 25 is going to get me to 35 grams. It's a lot of... This is going to go into the salt water. You can notice the color of the salt water right now is pretty clear. Here comes the iodized salt. It also asked me to put 2 drops of blue food coloring in there. 1, 2, and I'm going to use a popsicle stick here to stir it. Trying to get the salt to dissolve and the blue food coloring to spread out. This is a pretty saturated solution of salt water, pretty strong. And there you have distilled water and salt water. Step number 6 says list the components in salt water. Step number 7 says build and test the following electrical circuit in the fresh water and check continuity. Does the electricity flow? I have a 9-volt battery, alligator clips. I'm going to clip one of the ends of the 9-volt battery. Then this is a little light. I'll connect one end to the light. And just to check to see if my circuit works, I'll get the other end of the light on the other end of the battery. And I got a little bit of light there. And what I'm supposed to do is put the leads on either side of the fresh water and see if the light comes on. Okay. It's a little hard to do with one hand. But I have the alligator clip on one side of the water. I have my light lead on the other side of the water, and I don't see any light coming on. That means that electricity is not passing through the wire. Distilled water does not conduct electricity. Next, it says build the same circuit and check the salt water for continuity. So I'm going to move the saltwater cup into there and see if I can do the same thing here. It's a little hard to do with one hand. Go. Okay, oh, there we go. We have the light come on in the salt water. Salt water does conduct electricity. Can you see that okay? Very good. Step number 6, density in water. Very slowly pour half of the first cup into the inner side of the second cup so that the liquids join but do not mix. State your observation. Well, what I'm going to do is just take a couple of the drops of the blue salt water and very gently pour them in to the distilled water. I'm talking just a couple of drops. Generally speaking, if you pour a lot and it gets mixed together, you can't see the result, but you might be able to see the result here. You should be able to see a level of blue on the bottom versus a level of clear on the top. Let me look at it. Yeah, it's a little bit difficult to see. Take a real close look. The blue is on the bottom. It's more dense. The salt water is more dense. The clear is on the top. That's the distilled water. It's less dense. And this illustration can work good just with a couple of drops of water. Okay. State your observations. We see that the blue salt water goes to the bottom, and the fresh, dense fresh water, which is the distilled water, less dense, goes to the top. Thank you.